So here we are back at our familiar Ubuntu VM, and what we've done so far is we always decompiled an application, modified it, built it back again, and then we have signed this application with our own certificate. Wouldn't it be nice if we can modify an existing application with the original certificate? I guess this depends on the view, because this would also mean that the complete Android system would be broken and that you can infect people with malware by having original certificates. So for me, I would say, no, this wouldn't be that nice. But for an attacker, of course, this would be ridiculous nice. And this was the approach of this vulnerability. An attacker could modify an existing application with the original certificate by exploiting a nice behavior during the verification of this process. But before we jump right into this, let's verify what would happen if we modify an existing application. And therefore, I go into our original application directory first. So I open the files, apps, spacepan, and here we have the APK file. We can double click or right click open with Archive Manager. And then we've got the zip archive where we can directly edit those files. So we go into the assets directory and we use a file which is not in binary form, so no XML files. Let's see, skin, uiskin.json, this one right here. Okay, now we open this one and we make our modification. We say, for example, this one is now A2. We save this file and we say update. And now we have modified this APK archive right here. And let's install this application. So I right click, say open a new terminal, because then I'm already in this directory right here. And then I say adb connect. And adb install this application. Now it says, ooh, there is some check, and the check failed because the manifest.mf has an invalid digest. And this is why we get through this whole process, what these hashes are for and things like this in the signing section just before. So we know how to calculate this one and why the digest has been changed right now. So let's do this real quick. So we go into the assets directory, we go into skin, then we open the uiskin.json, and then we make also here our modification. And then we use this file now to calculate our SHA-1 sum. So OpenSSL, SHA-1, binary, uiskin.json. All right, now we pipe this through base64, and we replace now this value in the package archive. So I open this in a new terminal, spacepan, this one right here. Metainf directory, manifest.mf, and we look for uiskin.json. You do not need to do this because it will be a dead end at the end. So you can sit back and relax while I'm doing this. We have now modified this one right here, and we also need to change the hash in the signature file. Therefore, I copy paste this one right here. And then we use the OpenSSL command regarding to the name and the SHA-1 digest to calculate the signature file hash. So this is this one right here. If these things are too complex, an easier way would be to make this modification in our original application. So decompile this app, make this modification, and then build this app back again, because then all those hashes has been automatically updated and we can simply copy paste them out from there. But yeah, we are also ready for now, so this isn't really faster, but it's way easier. All right, here we have the second signature. So we, after changing this one, did I update this? I guess yes. Let's verify this real quick that I do not mess up something during this copy paste process. So uiskin is this one. Yep, that's correct. All right. And now we go into the signature file, this one right here. uiskin, and this one needs to be replaced right now with this one here. So we adjusted those hashes. This is a normal operation and everyone can do this. Let's see what happens if we try to install this application right now. We hit update, we close all those windows. Oops. And now we say open a new terminal and we say adb install. Alright, we still get an error, but it's not related to the manifest MF anymore. It's regarding to failed certificate, failed verification in the signature file right here. So here we can see we've got a new error. This is now regarding to install pass failed no certificates. It's not with the manifest MF. We have calculated these hashes correct and we also placed them in the correct position. So this part has been successful. But now it says install pass failed no certificate. By adjusting those files or modifying those files, we did break the signature of this APK. And this is something we cannot correct, because this is something that only the developer can do by having the private key. So we do not have the private key and therefore we are not able to modify these files. So how was this exploit even possible to circumvent this issue? Well, it did not circumvent the signing process because this is pretty stable and built properly. So there's no issue within the signing process, but there's an issue within the verification process. And this is something I would like to show you right now. Okay, so here I have restored the original version because we have modified the last one. So we have a clean base and we can install this application just to make sure that it's the original one. And we can install this. Success. Okay. So if we open this, we cannot modify those files. But what about adding a file? Well, let's see. Let's take, for example, this one right here, the APK tool meta information. All right, it has been packed into the file. Now let's try to install this one. Here we have the error that there's no entry for this file available in the application. So adding completely new files does not work. But what happens if we add a file with the exact same name? For example, if we add a new classes.dex file. So let's find this out. First, I'm going to delete this one, that we get the original state back. And now we add a new classes.dex file with exactly the same name. So let's see what happens. And here we've got this classes.dex. So let's see what happens if we drag and drop this one right into this. We can see the file size has been changed. So this file has been overwritten. It's also not working this way. So we cannot add two files with the exact same name into one single zip directory. Or can we? Well, let me get the original state right here. And then, let's have a look how this one would work. All right, here I have restored the original value back again. We can see the date is the same and also 2.1 MB. So this is the original classes.dex file from the SpacePang application right here. I go back into our Sieve application right here. And then I rename this file because adding new files with new file names is possible. So we renamed this to classes with Z at the end. And now we put this into here. And we can see, yes, we have both classes.dex and classes with Z at the end. Now let's open this zip archive in an hex editor. So I go back to the SpacePang application, this one right here, and I say open in terminal, ghex, and this application. All right, here we already can see those file names. So we are looking for classes with the z.dex. And here we have one. What we now do is we simply change this binary content by pressing this Z and replacing it with an S. All right, now find the next one. Here's one again. And the next one, that's all. Now let's save this file and open it back again to see what has changed. So I open it and voila, we've got two exact file names into one zip archive. So now's the question, what would happen if we install this application? Which classes.dex will be installed? Well, the answer is the last one that has been added by the attacker. And this was the exact vulnerability. So by having two exact file names in the zip archive, the last one gets installed and not the previous one. And this one also does not get checked, so the last one. The attacker is able to provide a new complete source code into this application. This could be, the original one which has been modified, or even a complete different application and having the original certificate. And this is ridiculous amazing, because it's like, this circumvention of the security issue is so genius. I'm super excited about this one. This is what hacking is about. And this is something you get with a lot of practice and thinking creative. And this comes handy for maybe other applications for you. So let's assume you have a customer application and they perform the verification in the same way that the Android system did in 2013. Therefore, you can bypass this with this check, or at least maybe you can bypass this. This is something you should try out at this point. After having some relaxing session, now you get your hands dirty, you have to hack this application. So let's face the challenge in modifying this application.